good drum and break.
Do you understand? I don't know what's going I got three questions. You understand?
But like when everyone's shaking that's the opposite. He's gonna end up taking. I feel like he's gonna end up taking pictures with Rachel's mom.
Oh wait, where'd you end up? I just literally that's same. I got a B first semester in English.
I saw you guys.
Oh, I did. I understand extreme.
I'll show you how.
Yeah, you see everybody in the box. She has.
What'd you get on that?
Someone just asked us to cover it.
I didn't think
Okay. Let's get started here. I like to finish this when we can. Number one, scatter plot. Scatter plot shows a negative slope.
Your -1?
Yep. So it's shows a negative slope. It's also strong. Correlation. So which one has negative slope with strong correlation? A. Done.
With strong correlation.
Yes. 2.
Why is it not good?
Why is it not?
Because is it negative? It's not negative. I mean, is it
You see this straight? Pretty much.
like why is it not good?
B. Because B is kind of hinting that it's not a very strong relation. 2. Set from the scatter plot, if each x value was decreased, what would happen to correlation R? And the idea here is that moving all the points, did it say to the left?
Decrease by one.
So decrease x value, so to the left. That doesn't change, or doesn't weaken or strengthen. Yeah, it does not weaken nor strengthen the words are failing me. Doesn't trend. Okay. So if we're not weakening the trend and we're not strengthening the trend, then the measurement of the relationship should stay the same. Okay. 3. In regression, which of the residuals are following, and this is just definition here, but residuals are always the difference mathematical difference between actual values of y and predicted values of y. So either you have that kind of thing known or you don't. This is really a shot at a definition. 4. Now there's a couple problems here, and the big problem is R for this problem is negative 1.08, is a problem. That's a problem.
Because it's only one.
Yeah. R should be between -1 and 1. Or is always between -1 and 1. The given value of R is nonsense. So yeah, it's kind of strange that the answer to this would be something like sarcastic, like the college should hire a new statistician. But that's actually the answer. Even if the tone seems weird for a question.
They do something like that on AP.
No, they would not do that for the AP test. Yeah, no snark on the AP test.
This is your snark.
It's my snark, yeah. Actually, this isn't even my snark. This is like,
You don't make these?
no.
Oh, I know you make these.
I mean, I make them, but I pull the questions from other places.
Oh, okay.
So
This
this,
is that's not your
that's not my
wording.
personal snark.
Really? Okay. It's clever. I like it.
I think that's Darren Starnes. That's what it sounds like to me.
Like what?
The guy who wrote the book, one of the guys, his name is Darren Starnes. Sounds like it's kind of a snark.
Oh, whose is this?
That's one of the weirdest things about like when I started teaching is meeting these people who wrote the book.
Taylor.
Yeah.
Are Nora and Austin?
Yeah.
Oh,
No.
sorry.
Yeah.
That value of R is nonsense, so E. Yeah, E.
For number 2, the only thing that would actually change.
So cute on this side. No?
Yeah, if you change the relationship, where the data is. Yeah, so we change the data. Yeah, just moving it around doesn't do anything. 5. A researcher finds a correlation between greed and superciliousness to be -0.4. So the problem with this one is that linear relationships are only for quantitative value data.
Is that like for everyone?
Always. Always. Quantitative data. Greed and superciliousness,
Or categorical?
yes, are categorical. So,
So none.
that's the nonsense question, yeah.
Yeah, I'm like, what the hell is
So the
this?
answer is
Nonsense. This is a nonsense question.
I like that answer. Nonsense.
You couldn't do it. You need more information.
For an answer, then you have to answer.
E.
Oh, I'm sorry. You could do it. You would just square percent.
So you're just gonna square negative?
Yeah. So,
But what if it said like that, found that like, if it talked about the number of values kept in traits, would that be then quantitative? It's like the number of people?
yeah. As long as the variables that you're given are,
Numbers?
yeah. If these two were actually quantitative, to get the percent variation, you would square R. That's it. Six. Okay, what would we estimate the height of an average tree? The average height of trees having a trunk diameter of 7 inches, and this is just put it into the equation. Do we have an equation yet?
It's right there.
Yeah, is that negative 3.6?
Yes.
Yeah.
Okay, so we got negative 3 point predicted height. This height? Predicted height, average height. That's going to be equal to negative 3.6 plus 3.1 times, we're just throwing 7 in there. That gives us 18.1 inches, yeah? Not a whole lot to do there, right? 7. The following are resistant. A lot of people have asked about this, and resistant what does that mean? That means that the statistical measurement is not affected by the presence of outliers.
So the outliers like don't change the information.
Well, it changes it, but not very much. Okay. So what are resistant measures?
The X and Y values.
What are
Are we
non-resistant?
using the information number 6 still?
No.
Oh, okay.
Okay. So when I say statistics, I mean things like the mean. The mean actually is not resistant. However, the median is resistant.
Yeah, Y.
The median is resistant because if you just knock out
One number.
yeah, it doesn't really change the IQR range because you're talking in percentiles.
But it would change the mean.
It changed
Because the values.
it changed the median minimally, but it would change the mean drastically. Yeah.
It would,
So the median is resistant, the mean is not
the
resistant.
mode's not resistant. Or it is resistant.
The mode is resistant, yeah.
Because it won't change the value.
Exactly. What else is not resistant?
Y values.
Correlation of
What about like the X and Y values?
X and Y values aren't statistical measurement.
Okay.
They're data.
So like what about slope? Is that
Slope is not resistant.
that means correlation.
Okay. What else is not resistant? Y-intercept.
That will change.
What else is not resistant?
Non-resistant is that it is.
it's gonna get affected? Yeah.
Resistant is that it's not effective. Effective.
So what's the question exactly asking?
R, correlation coefficient. What else is not resistant? Coefficient of determination.
What's a correlation coefficient?
The number that's like how correlated numbers are like -1,
Like
0,
if
and 1.
Correlation coefficient is R. Coefficient of determination is R squared.
Okay, coefficient of determination is the one that always.
It's like the variation.
Yeah, coefficient of determination is a variation thing.
R always has to be correlation coefficient always has to be between -1 and 1, but coefficient of determination doesn't have restrictions.
No, it does have it. It's going to be between -1 and 1.
They're both between -1 and 1.
Yeah.
But I don't really get how the median is not resistant. I mean, it is resistant because like if a number gets knocked out and it's like the number, all the
Mhm.
numbers are together all
Well,
odd, and then
what's going to happen? Yeah, what's going to happen is like it's going to be. Let's say we knock out a high outlier. Okay, that means that the median is going to move to the next lowest number.
but it's not going to change drastically.
Not going to change drastically,
Okay.
but it's just going to move just to the next one. Basically, anything that has to do with regression line is not resistant. Regression lines are not resistant.
Okay, so if it's asking, what will not change. Okay.
Yeah.
So it's D because the least square line. What is the least square line?
A plus bx.
A plus B is, and that's regression.
That's regression.
That's regression. So that will change, and so will the correlation coefficient.
Yeah.
So that's why it's D and it's neither.
Yep.
Can you not do double negatives?
I don't get that,
confused.
I'm so sorry
It's
about
a
that.
double
I know.
negative. Last test I got the same thing
I
happen.
know.
think.
It's gonna happen again. I can't.
Okay.
Yeah.
Okay. I'll
It's a stats class. Sorry. So sorry. It's gonna get worse.
What?
Double negatives.
Double negative.
It's gonna get worse.
I don't get it though. Like neither the least
I
square
do
line
not
or the
mind.
correlation, like they're not resistant. Is that what it means? Like when it says neither the following are resistant, it means like neither the square line nor the correlation. Or does that mean that it's saying that they're not resistant?
Yeah. LSRL is not resistant. Or regression line is not resistant. Coefficient, correlation coefficient is not resistant. All right. Any other questions on resistance? Long story short. Regression is not resistant. Ocho. The Ocho. Data set has correlation coefficient 0.67 and negative point. I'm sorry.
C. C.
Data set A has correlation 0.65. Data set B has correlation negative 0.65. Okay. But notice that they didn't give you the way that the data looks. You can compute a correlation coefficient even if the data is clearly not linear. So in other words,
You can have the same
data set A could be linear and data set B could be curved
and still have the same.
and still have the same correlation coefficients. So we don't know which one has a stronger linear association.
If they showed you a graph that had all the points and one was negative
Yeah.
and the other one was positive, then you could say C. That
Then
they're
you
the
could
same,
say, yeah.
then they're the same thing. Okay.
Mhm. So since the data or correlation no.
So 0.65, whether it's negative or
Since correlation can be computed
distance is 0. So they're equally the same from 0.
for
so
nonlinear
that's why
data.
they're the same. But at the same time, if it's one line is like this and one is like that, then they're not different strings. But if one of them is this and one of them is the thing and one of them is a curve, then they're not the same level of strings.
The least
So
square.
we don't know what the graph is, so you can't determine what it is, this information that they give you. The answer is D. Yeah, because you don't know what the graph looks like, so you can't tell if it's the same. If the numbers were to give you some of your graphs to see, so it's still D. So it's still D graph. Like if they showed you the graphs, then you could say it's D, because if you see the same exact pattern, just one's positive, one's negative. Because correlation means like if it's positive, if one goes up,
Well, we don't know.
but you don't know because you don't know how the graph looks.
Like there's strong correlation, but we don't know if it's strong or not. Because
Yeah.
you can only tell that by the graph. So basically, we don't know it's one positive, one negative.
Mr. Fagan, what is the least square regression line?
A plus BX.
Like, you know correlation, like.
Okay. You can I mean you can't use R unless you know that the data looks linear. If the data doesn't look linear, then R becomes nonsense. If the R, they don't tell us anything about R, whether or not the data is linear, so these values of R's don't mean anything anymore, or they have no real meaning. Okay.
What is is A the y-intercept?
A is the y-intercept, yeah.
And then B is
Slope. B is slope. Okay, set of data relates the amount of salary to performance rating, the least square regression line, y hat equals 1400 plus 2000x, where y is estimated raise and x is performance rating. Which of the following is not correct? Okay, so some of these are going to be correct, some are not. Is it correct to say that each increase of 1 point in performance rating will increase the raise by an average of 2000?
Yeah.
Yes. Is it true to say that this equation produces predicted raises with average error of 0? Now before you answer that, When they say average error, they mean add all the what are we calling it? Add all the deviations together and divide. Well, if you add all the deviations together, don't you get 0?
Yeah.
So wouldn't the average be 0? Yeah, the average is going to be 0.
How do you know that? Like, how do you know the deviations?
Deviations always add to 0
Deviations always have to.
by definition.
Okay.
Maybe not by definition, but mathematically it's always going to happen.
Okay.
C. A rating of 0 will produce a raise of $1,400. It's true. Just plug in 0 and you'll see that that's true. D. The correlation for data is positive. Can we tell that the correlation is positive?
Yeah.
Yeah.
There's nothing because it's plus.
Yeah. B is plus. B is positive. So yeah, all of these are true.
Wait, why is D true?
B. Oh, deviations always add up to 0.
So the average error is always going to be 0.
Average error is always going to be 0. All of the above are true. You know, if you really think about this, if you answer E, you're saying that all of the above are true is not correct.
That means they're all false. See, it's a double negative once again.
What? Wait, what? What happened?
Huh?
So it's not E?
E is the correct answer.
Wait,
So,
that's
that's
so
really-
funny.
Just for the right answer, all of them are wrong.
If that turned up on the test, if that turned up on the
Yeah.
test, then we picked that.
All of the above are true means that all the above are false.
We're confusing people.
Yeah, okay. So
We are really confusing
everyone
people.
just forget it.
Let's not do it.
Everyone
So
just
what's the
forget it.
answer?
Answer is E.
E.
So it means that none of them are.
Yeah,
The intention here is to say that all of them are correct.
So A is later, or is it doing that?
Okay, listen, if A and B were both wrong, that would mean that all of them are true. That all of them would be
I
wrong.
shouldn't have opened my mouth. I really shouldn't have.
Wait, I know. If A and B were wrong, then that means that all of them would be wrong.
Easy answer. Yeah.
Yeah, if
I
so,
get it.
so if we put any of the other answers, we'd technically be wrong. So all of them are correct or true. So
Next, number 10. Number 10.
10. No, 10 or 9? 10.
I get it.
10. 10, 10, 10. Okay, so we're seeing a curve in the residual plot. Okay, since we're seeing a clear pattern, a linear regression is not
Is number 10?
a good choice for the data.
Because it's not a line.
Yeah. A residual plot, no, not that's not a line. For the residual plot, a residual plot should
D.
I don't get what the difference is.
He's explaining it right now.
a residual plot should not have a clear pattern.
Meaning it should be scattered.
Yeah.
Oh, didn't you say that nothing would ever be like it'll like rarely ever be a lot like a clear pattern? It's gonna be scattered around.
Yeah. But this one has a clear pattern.
So that contradicts.
That contradicts
that
linearity. Yeah.
Okay.
Like it would be linear, but it would like if you draw a straight line, not all of them would be on it, right?
You shouldn't have to. If you draw a straight line, if you draw the curve, they should not be on that.
Yeah.
They should be scattered around.
Some of it can touch it.
Yeah.
Okay. I think we can get to 11 then.
Yes, please.
Um,
10?
so a residual plot doesn't have a pattern.
No. A residual plot should not have a pattern. Okay. You can't say what a residual plot will look like.
Right.
You're saying what you're looking for in a residual pattern is in a residual plot is no pattern. When you see a pattern in a residual plot, it means that the linear, a line isn't a good choice. A curve might be better. Yeah.
Your number 9 should be number 8.
No.
Yeah, because
8 disappeared.
it's okay, we still love you.
I'm confused.
That's 8, we skipped number 9.
Oh, I see. So, bye-bye.
Number 9.
Oh, we just didn't write it down. We just didn't write it down.
9 should be all of the above are true. Yeah. How could you tell if...
Probably here.
I don't know how it would be inconclusive. I don't... Yeah. Yeah, you have to make a decision. Okay, let's go to 11. All of the following statements contain an error. So what we're going to do is we're going to take a look at what that error is. A. Okay, everyone. Let's keep it together. We only got a few more to go here. Number 11. What's the problem with A? Football position.
Be stronger? No, because
Is in
they
position categorical.
they're not very. What'd you
Football
say?
position is categorical.
Oh, so you can't. Oh, okay.
Oh. That's
Oh, okay.
false.
Good job, Brandon.
B. What's the problem with B?
Yeah, it's a good job.
Correlation between planting rate and yield of corn is found to be 0.23.
Stronger?
Doesn't know what to do.
The more you crops you.
Wait, isn't this I don't know. Is it categorical?
No, rate.
Oh, right.
Yeah. This one looks fine.
No, it would be a stronger one, I think.
Doesn't matter who's stronger.
Well,
I don't think you would know
okay,
that.
okay. We can't really judge whether or not what the our value of R should be.
Okay. Because we don't know it. We
Yeah.
didn't do research.
They could do
So this
better.
one looks okay.
Yeah, but there's linear.
C. The correlation between gas mileage and its weight is 0.71 mpg. The problem with that seems okay, except for R shouldn't have a unit. Yeah, thank you. R not have units. That's the problem with C.
Oh, thank you.
Have a good R does not have a unit. D. We found high correlation R equals 1.09. Okay, we're good with that one, right?
Wait,
1.09. Can't be over.
that is a blunder.
Yeah.
Wait, I have a
Which
question.
one's correct?
Quantitative data can have correlations
Wait, so-
too, right? But they just can't be regressions,
We're
right?
looking for
No.
the right one. Okay. We're looking for the one.
We're going to deal with categorical data later.
That's why the answer is E.
E. We found a correlation of negative 0.63 between gender. Yeah, there it is again. Gender
So R can't have a unit.
and party.
So if for part C,
Hang on, let me finish typing. Okay. Are categorical. So B is probably the correct answer.
if there was no MPG on letter C, then it could be right.
Yeah.
Okay.
The only thing wrong with that is that MPG there.
Wait, why can't it have
Which one?
12. An LSRL predicts the height of a tree in the first 10 weeks in the nursery to be y hat 3.2 plus 1.8x, where y hat is predicted height. A. Okay, so this is kind of short response now, right?
Yes.
A. Interpret the meaning of the y-intercept and the slope. Okay, so a tree for y-intercept equals A, and that's equal to, what was A?
Y-intercept.
3.2? A tree that spends 0 weeks outside the nursery is predicted to have a height of 3.2 and inches.
What's the point of that?
Hmm?
The second one?
You're supposed to interpret the value. That's the interpretation. Next, for part A, we're looking at the slope. So slope is equal to 1.8. Yeah, B, which is equal to 1.8. It means for every increase of one, and what are the units here? 1 week? Yeah, of 1 week outside the outside the nursery.
It will go up.
What will go up?
The height?
Good. The predicted height, though.
You need to say predicted, right?
Yeah. The predicted height increases by 1.8 inches. B. Estimate the height of a tree that's been outside of the nursery for 6 weeks. Easy.
Just plug in 6.
Predicted height, yeah, plug in 6, is equal to 3.2 plus 1.8 times 6 equals 14 inches. Awesome. C. The actual height of a tree that's been outside of the nursery for 6 weeks is found to be 12.5 inches. Residual. Residual equals actual minus predicted, which is equal to, the actual is 12.5
Yeah.
and predicted is 14, gives me a residual of negative 1.5 inches.
Good.
Don't you wish they're all like that?
I do.
I think you should.
I mean, you should have predicted by value and residual for like half the question.
Predicted and residual?
For half the question.
You might not be disappointed on that.
I figured.
Don't get my
Thank
hopes
you, I
up.
love you.
I just think, I don't know how
Half the questions are gonna be residual
That's what I'm
and
fine
prediction.
The only thing that worries me is like, you know how you like as a
Let me finish this and then we'll get to that, okay? Okay, 13. A regression line between train departure time after 5 and travel time found an R squared of 0.66. The relationship has a positive correlation. So what is the value of R?
Don't you just do
Square root, yeah.
Yeah, you're just going to do square root of 0.66.
0.81?
0.8124. Is that A?
Mm-hmm.
Good. B? Explain R squared in context.
Oh, that's the percent one.
Yeah.
Okay.
So you know what I'm going to do? I'm just going to go right back to here.
You
I'm going to copy.
do 0.66.
I take that right there,
66%.
copy it, and paste it. Like literally. Approximately 66% in
This one you could memorize. What R squared? Anytime it says what is R squared, you have to write that. Response variable is, let me tell you.
travel time.
How do we know that that's a response? Because it depends. Okay.
Departure time. To travel time.
Can be
Oh no.
instead of writing linear regression, never mind.
LinReg. LSRL. Either of those will work.
LSR.
Which quantity is minimized by an LSRL?
No sé.
Wait, I thought.
Okay, and you know the answer here is is the actually the part of the question. LSRL stands for least squares regression line. So what's minimized? The square regression. square root.
What is the question asking?
It's kind of a how do I say this? Like explanation on what is actually going on.
Okay.
And what's actually going on is for a least squares regression line is the residuals that you get. We're minimizing those residuals. We're minimizing the square of those residuals.
But how will we know that?
Hmm?
How will we
We're
know?
minimizing them because we're trying to get rid of the
You have
residuals?
to have like faith in the process that this is actually what's going on.
So when it asks what quantity is minimized, is it always the square?
It's always the square of the residuals. The sum of the square of residuals. Which is kind of the same thing as saying the sum of the square of the deviations.
So it's always.
Yeah.
The question is asked, and it's always been that.
Okay. Also, so square regressions. Oh wait, no, hold on. This is supposed to say residuals. I'm so sorry. Square residuals.
What do you mean by square residuals?
Good question. Actual minus predicted squared is minimized. Which is the same thing as saying as y minus y hat squared is minimized. All of that means the same thing. Last questions. All right, I'm going to turn this off then.